right, so starting back up on the year turn, hopefully you guys got 0 and pi over 3 and 5 pi over 3. Okay, so I'm going to give you one more that we're going to kind of work through together to solve, and I want to do the cosine double angle formula just to kind of show you, because there are 3 options for that. So I want to kind of talk through how you would go about choosing your option. So cosine 2x minus cosine x equals 0. Okay, so when I look at the cosine equations, there's like 3 that fall under the cosine of 2u. So I can either do the one that's cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. So the one that I'm going to pick to replace this with is the one that only contains cosine squared. It doesn't introduce another trig expression, because that way I can then look to see, can I factor it? So for this one, I'm going to substitute in 2 cosine squared minus 1. And then we have minus cosine x equals 0. So I'm going to just rearrange the terms. 2 cosine squared x minus cosine x minus 1 equals 0. And then we are going to kind of treat this like, I'll kind of sidebar this up here to the side, like 2x squared minus x minus 1 equals 0, because it's cosine squared and just cosine, so it's like cosine squared minus cosine. So you would factor this one, 2x and 1x, and then 1 and 1, and then it would be minus and a plus here. So we're going to factor this the same thing, except for instead of just a plain old x, it's going to be cosine x. 2 cosine x plus 1 cosine x minus 1 equals 0. I'm going to just shift that over so it's all in the window. And we set each one equal to 0. 2 cosine x plus 1 equals 0. Cosine x minus 1 equals 0. And then we solve, so cosine x equals negative 1/2. And cosine x equals positive 1. So this is at 0. That's where my x value is 1. And then where is my x value negative 1/2? And that's in the second quadrant, which is 2 pi over 3, and the third quadrant, which is 4 pi over 3. All right, so that's how we would go about solving if it's the cosine option. All right, so the second type of equations are ones like this, where it's telling you that your theta has to be between a certain thing. So for this one, theta is going to be between 3 pi over 2 and 2 pi. That means that it would be located in the fourth quadrant, okay? So we're going to go ahead and create our triangle like we've done in the past, because they tell me that, there's my theta, cosine of theta equals 5 over 13. So ca adjacent over hypotenuse, so 5, and then that's 13. And then this one's going to become 12. It's going down, so we're going to make that a negative 12. All right, and so now we want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So we have our sine theta from my little triangle over here. Oops, shifting it back. Sine of theta from my triangle over here is negative 12 over 13. My cosine of theta was given to me, which is 5 over 13. And my tangent of theta is equal to negative 12 over 5. All right, so if I want to do sine of 2 theta, it's equal to 2 sine theta cosine theta. So it's going to equal 2, well, sine of theta is equal to negative 12 over 13, so times negative 12 over 13. Cosine of theta is equal to 5 over 13, so times 5 over 13. So sine of 2 theta is going to equal 2 times negative 12 over 13 times 5 over 13. So we've got negative 120 over 169. That's what sine of 2 theta is equal to. Okay? So for cosine of 2 theta, it's going to be the same thing. It doesn't matter which one you use. So this time I'm going to just show you for cosine. I'm going to use the first one, which is cosine squared minus sine squared. So cosine 2 theta equals, and the reason why it doesn't matter this time is we have all of my terms for sine and cosine. So I'm going to do cosine squared minus sine squared. So cosine 2 theta is going to equal cosine, which is 5 over 13, squared, minus sine squared, so negative 12 over 13 squared. So we get 25 over 169 minus 144 over 169. Okay? Cosine 2 theta equals, and we can kind of go from there. All right?